At this time, please open up the reflection notes and we'll go ahead and fill it out together. Through this video, I want you to learn how to reflect something over the x-axis or the y-axis. So let's start with example 1. Triangle ABC is being reflected over the x-axis. And what I'd like you to do is I'd like you to take a highlighter and I'd like you to highlight the x-axis. I can't tell you how many times students will just accidentally reflect it over the y-axis instead of the x-axis because they weren't fully paying attention. So highlighting it, make sure you're paying attention to what you're doing. You're reflecting it over the correct line of reflection. Letter A, draw and label the image triangle ABC prime. So before we make our prime image, what I'm going to do is I'm going to go ahead and fill in the coordinates for A, B, and C. So A, you want to fill in your notes, is we go to the right once, we go down 1, 2, 3, so 1, -3. You're always going left or right first, and then you write down the vertical movement up or down. B is 3, 0. Because we went to the right 3, we go up or down 0. And then C, we go to the right 4, and we go down 2, so it's 4, -2 is the coordinate for C. Now what we're going to do is we're going to create our image by reflecting the pre-image over the x-axis. So B is really simple. When you flip it, it remains on the x-axis, so this becomes B prime. Then I'm going to move A. A is 1, 2, 3 from the x-axis, so I'm going to go upwards. 1, 2, 3 from the x-axis, and I'm going to mark A prime. And then finally C prime. C is 2 units from the x-axis, so I'm going to go upwards, 1, 2, and I'm going to label that C prime. And then I'm going to do my best to connect these. You'll want to connect them using a ruler at home because you want to be able to see that the original figure is the same as the new figure, and you should be able to see that they're congruent. Because when you perform a rigid transformation, the new image is the same size, it's the same shape, they're congruent. You just change the location. So we flipped it over the x-axis. Now A prime is 1, +3. B prime is now, it's still 3, 0. And then C prime is 4, +2. And I want you to just take in the pattern here. The 1, the 3, and the 4 stayed the same, but the -3 became a +3. The 0, well, you know, 0 is neither positive nor negative, so there's no change there. And then -2 became a +2. And we flipped it over the x-axis, and you'll notice that what changed was those y values. All right, let's continue. B, it says we can use an arrow to describe this reflection. So it shows you we're reflecting triangle ABC and making triangle ABC prime. And tell me more about this figure. Is it congruent or similar? We already said that it's congruent. Similar would be the same shape but a different size. Example 2. Triangle ABC is reflected over the y-axis. So now we're reflecting over the y-axis. So go ahead, take a moment and highlight the y-axis. And then we're going to label our points A, B, and C. So A is 1, -3. B is 3, 0. And then C is 4, -2, just like before. And then A is 1 unit from the y-axis, our line of reflection. So I go 1 unit to the left to make A prime. So since A was 1 unit to the right, we're going to go to the left 1 unit to make A prime. Then C was 1, 2, 3, 4 units from the y-axis. We're going to go 1, 2, 3, 4 units the opposite direction to make C prime. And then B prime was 1, 2, 3 from the y-axis. We go 1, 2, 3 in the opposite direction to the left, and we form B prime. And then I'll connect these. And you'll see that these two look congruent. Same size, same shape, they're just in a different place, or the image is just in a different place now. So A prime is now, let me look where A prime is, -1, -3. B prime is -3, 0. And C prime is -4, -2. You'll notice that the y values stay the same. We still have -3, 0, and -2. But what changed when you flipped it over the y-axis was the x values. So a 1 became a -1, the 3 became a -3, the 4 became a -4. So it was the opposite of what it was originally. Example 3. Draw a triangle JKL which has coordinates J, K, and L. I'm not going to read them, you can see it. Let's go ahead and graph these points. So letter J is -6, 2. 1, 2, 3, 4, 5, 6. +2. And I'll label it J. It's very important that you label it right away because sometimes you forget which is J, which is K, which is L. 1, 3 is K, and L is -1, 2, 3, 4, and then -10. And then why don't you go ahead and connect those. I'll do my best to make them look straight. And there's our triangle JKL. From here it says, draw the image triangle JKL prime after reflection of triangle JKL over the x-axis. So I'm going to highlight the x-axis. And then K is 1, 2, 3 from the x-axis. So I'm going to go down 1, 2, 3 to form K prime. And then J you'll see is 2 above the x-axis. So I'm going to go 2 below to make J prime. So 2 above was J, 2 below is J prime. And L is 10 below, so I'm going to go upwards 10 to make L prime. And then I'll go ahead and connect L prime to K prime, and then L prime to J prime, and then J prime to K prime. And you'll see this blue triangle, JKL prime, is the same shape and the same size as JKL. We'll write our new coordinates down. So J prime is at 1, 2, 3, 4, 5, 6, -6, -2. And you'll see that when we flip it over the x-axis, again, we're changing the y value. So let's go ahead and guess for K. I would say without even looking at where it is on the grid that it's at 1, -3, and that L is at -4, +10, because we're switching the y values. And then I'm going to come over here, I'm going to check K prime. I go to the right one and down 3. That's correct. And then letter L, I'm counting out to the left 4 and then upwards 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, and you get to L prime. All right, then what we're supposed to do is we're supposed to take JKL, that triangle, and flip it over the y-axis. So now I'm going to highlight the y-axis in green, and we're going to take our blue triangle, JKL prime, and we're going to make JKL double prime. All right, so K prime is 1 to the right, so I'm going to go 1 to the left to make K double prime. And I'm going to circle it just so it's easier for me to see where K double prime ends up. Then we have J prime is 1, 2, 3, 4, 5, 6 to the left. So we're going to go 1, 2, 3, 4, 5, 6 to the right of the y-axis to make J double prime. Circle it again. And then finally, L prime is 1, 2, 3, 4 to the left. So I go 1, 2, 3, 4 to the right to make L double prime. And then I'm going to connect J prime to L prime, and then J prime to K, well, I guess double prime, sorry, and then K double prime to L double prime. And you'll see again, this is the same size and the same shape, but it's just in a different place. So I'm going to write down J prime, K prime, and L prime, those points before I scroll down, and you can fill in what you need to on the notes. So J double prime, and I think it's down here is where you fill that in. I can't see the bottom of the page without deleting what I've written. So let's look at J double prime. We're at 1, 2, 3, 4, 5, 6. Looks like we're at 6, -2. And that would make sense because the -6 became a +6. And then let me look at K double prime. Looks like we're at -1, -1, 2, 3. And again, it makes sense. 1 went to negative, became -1. And then finally, we're at L double prime. Let me find L double prime. 1, 2, 3, 4, and then upwards 10. So +4, +10, and that change was from a -4 to a +4 because those x values change when you flip it over the y-axis. Okay, so that's just where you record all of that information we just recorded above. And then it says, describe a different combination of two reflections that would move triangle JKL to triangle JKL double prime. Take a second, think about it, and then start the video again. All right, so now that you're starting the video again, you should have just seen that instead of flipping it over the x-axis and then the y-axis, what you could have done is flipped it over the y-axis first and then the x-axis, and you get it to be in the same place. So just put the order as different. So you flip or reflect over the y-axis, and then second, you reflect over the x-axis. Is this new image congruent or similar? I think you know by now it's congruent. Same size, same shape, just different location. Ready for example 4. Draw triangle ABC which has coordinates A, 1, -1, 3, 4, and C, 5, 1. Draw the image triangle ABC prime after reflection of triangle ABC over the x-axis. All right, so 1, -1, we have A, B is at 3, 4, and then C is at 5, 1. And we make our triangle. Draw the image after reflection over the x-axis, highlight the x-axis, and then we'll quickly flip. A prime is 1 above since A was 1 below. C prime is 1 below because C was 1 above. And B prime is 1, 2, 3, 4 above, so we go, well, B was 4 above, so we go 1, 2, 3, 4 downwards to make B prime. And then we have our new triangle. A prime is 1, 1. B prime is 3, -4. And C prime is 5, -1. And since we are flipping it over the x-axis, the y values change because the vertical portion is what moved. So from -1, we changed it to 1. From 4, we went to -4. From +1, we went to -1. And the x values remain the same. So an x-axis flip, the x values stay the same. And that's all we have time for in this video. We'll continue in another video to finish this set of notes.